Alright, welcome to this review video that I'm putting together. This is the same worksheet that you guys did throughout class, but I'll say this again, it's broken down by learning targets, so every single question on it, I mean these questions are literally straight off of the test. So I said it in class, but I'll say it again. If you can master, if you could get everything right on this or on the formative, again, if you redo the formative, you're going to get an A on the test, I promise you. Okay, because it is like the same test. It's the same questions, okay? So let's start here. I'll just go through question by question. If you are good with this, you know I don't really need help on this learning target. Fast forward a little bit. Go to learning target 3 or whatever learning target you need to. So I'm going to go right in order. So let's start here. First of all, here's our learning targets. I can understand a rational number as a point on a number line. I can extend the number line. I can extend number line diagrams to represent points on a number line, okay? Now, number 1 says, create a vertical number line that represents even numbers. So here's your key thing. There's 2 key words here you need to know. You need to know what the word vertical means. Okay, some of you are still mixing this up. The word vertical means up and down, okay? And the way I remember it is I know that, like, as a basketball coach or a football coach, you know, I like to know what my kids, what is their vertical jump. In other words, how far can they jump off the ground, a vertical jump. A vertical jump, you jump straight up when you vertical jump. So think of it that way. So let's go ahead and do that. So we're going to start with our vertical number line. Okay. Now, the biggest thing that we got to remember when we're doing this is that the bigger numbers always go on top of this number line, on this vertical number line. Some of you mix them up. You put your bigger on the bottom and your smaller on the top. Make sure you actually put the bigger numbers on the top. Okay. So I'm going to put 22 up here, and I'm going to put 12 down here. Now, everything in between, I'm gonna do whatever it told me I needed to do. And it says I need to represent even numbers. So I have to ask myself, well, what is an even number after 12? Yeah, 14, 16, 18, and 20. Okay? So that's all I'm looking for there. Think of a thermometer. If we get to the test and you go, oh shoot, I don't know if a vertical is, if the bigger number goes on the top or the bottom. Think about a thermometer. If you had a thermometer, here would be your thermometer. 100 degrees would be up here. 30 degrees would be down here. The smaller number would always be on top. Okay? So that's all there is to that question. Just putting the even numbers on a vertical number line. Okay, now we're going to create a horizontal number line. Okay? We're going to be showing fractions between 3 and 4. So I have 3, I have 4. Okay? Now, let's think about this. We're going up by an interval of 1/6. That means every single section here is going to be 1/6 more than the previous one. So the first thing here is I need to add a sixth, 1/6 to 3. And that's going to give me 3 and 1/6. Some of you were just leaving that as 1/6. No, it has to be the whole mixed number, 3 and 1/6. Well, the next one's going to be still 3 wholes, but now we got one slice of pizza that we added we added 1 slice out of 6 to that 3. Now we're going to add 2 slices, so now we got 2 out of 6. Okay, now we have 3 and 3/6. Okay, then we have 3 and 4/6, and the last one 3 and 5/6. Okay, some people put another one right here. This is wrong, but I just want to show you what some people were doing. They were saying up in 3 and 6/6. Now think about this. That means 3 entire pizzas right there. That's 3 pizzas. And then we have 6 out of 6 slices. Isn't that an entire other pizza? So we actually, 3 and 6/6 is 4. So you would not put 3 and 6/6 on this number line. 4 is 3 and 6/6. Okay, so you're just going up by whatever the interval is. Okay? All right, learning target number 2. Now we're going to be able to interpret statements of inequality. Okay? About the relative positions of 2 numbers on a number line diagram. In other words, you're comparing numbers. So let's compare these. Now I said, if you're ever going to compare fractions and decimals, you either got to turn them to fractions or you got to turn them to decimals. Now I'm going to tell you it's a lot easier to turn this to decimals. That's already, I can zoom in here a little bit so we can see that a little bit better. Okay. There it is. That's already a decimal. So we don't got to do anything with that. But the other one, we want to make sure we do something with that. Okay. Now this means 8 whole pizzas and a partial pizza. So I know that this is going to be 8 point something. Now I got to do something with this partial pizza. I got to figure out what actual decimal that partial is. And the way we do that is we do 3 divided by 4. we do numerator divided by denominator. If you ever get confused and you accidentally do 4 divided by 3 or whatever, just think about it. How do you say that number? You say 3/4. Well, you divide it in that order. When you do that, you get 0.75. Now, we already knew that it would be 0 because this is a partial pizza. You can't have a whole pizza. So you're going to tack on this decimal right here, up here, 7.5. So now we have $8.75, and we have $8.77. Clearly, $8.70 would be larger here, okay? Down here, okay? Here's my 2/3. This is already a decimal, so let's do this one now. So I got to do 2 divided by 3. And yes, you can use your calculator on the test and everything. That's going to be 0.6 repeating. What repeating means is it's 0.666666 forever. Goes on forever and ever. I could draw as many 6s as I want on here. Okay, so all those 6s are there. Okay? So you got to make sure you put that little line, because some people say, they leave it as 0.6 and they say, okay, that's 0.6. No. Because this is 60 cents. 0.6 is just 60 cents. This is actually 66 or 67 cents, but that's actually high. That's a bigger number right there. Okay? So going back here, we know that it's 0.6. Now, is 0.6 larger than 1.5? No, because you have one whole pizza there. You don't have any whole pizzas. You just have 0.6 repeating of a pizza. Therefore, 1.5 would be larger here. Okay? Last one. We got 6.3. We got 6 1/3. So I know this is going to be 6 point something, and then I do 1 divided by 3. Again, you got to make sure you say that it's repeating. Okay? It's repeating. You must know that. Okay? So we're going to take that right there and we're going to tack it on. 6.3 repeating. Now this is the one a lot of students were saying, okay, these are equal. No, they're not equal. Again, think about it in terms of money. This is not $6.03. These are dimes. This is $6.30. Okay? And this right here is $6.33. Okay? $6.30, $6.33. Because again, if we punch this in our calculator, we get all these 3s. Now keep in mind, when we're talking about money, we only go to this place value right there. And you can see 33 cents. You can see that's just 30 cents. This one is larger. Okay? So it's numerator divided by denominator. Okay? Let's go on to the next page. Okay, I can express a whole number as a product of its prime factors. Guys, you need to know this. When it says product, that means multiply. And then we know what prime factors are. Guys, this is asking for the prime factorization. Don't miss this tomorrow, because you all know how to do prime factorization really well. So there's no sense in missing it, because you're going to use this every single time you do GCF and LCM. So you may as well make sure you know it, okay? What that means. Product of its prime factors means prime factorization. Okay, I'm going to do 6 and 8. Just so you know, I could have also done 2 and 24. Either way, it doesn't make a difference. You're going to get the same result. I'll show you here in a minute. Okay, this 8 would be 2 and 4. Okay, this would be 2 and 2. Okay, this one over here would be 2 and 12. It's going to be 2 and 6 and 2 and 3. Now, just so you know right now, this is not the answer, guys. This is not the answer. That is not the answer. This is not the answer. That's not what prime factorization is. These are the trees. The prime factorization is actually writing the numbers out multiplied by each other. So here I'm going to do 2 times 2 times 2 times 2 times 3. Okay? That's what it is. Okay, that's the prime factorization. It's 1, 2, 3, 4 2's, which we have, and then times 3. Now, if you look over here, this would be the same result. We got 1, 2, 2 2's, 3, 4 2's, just like we have, and a 3. So it doesn't matter how you start it. Okay, let's do the next one. I'm just going to go ahead and break this to 2 and 40. Now, you could have also done many other options. I'm just going to go 2 and 40, and then 2 and 20, and then 2 and 10, and then 2 and 5. Okay? Remember, this is not your answer. Your answer is 2 times 2 times 2 times 2 times 5. That's your answer. All right? Let's go on here. Saying whether they're prime, composite, or neither. Learning target number 5. Okay? 27. First thing you should identify. Remember, guys, even even or odd. That's number one that you have to do. Tell me if it's even or odd. So we go through here. Okay, this is odd. This is even. It's an O. I guess I can put it out here. This is even. This is odd. This is odd. Okay. Now, when I say it's odd, what I'm asking you to do is I'm saying, can this have a factor of 2? No. Can it have a factor of 4? No. Can it have a factor of 6? Basically, what I'm telling you is all these even numbers, 2, 4, 6, 8, and I could go on forever, 10, 12, 14, all those, none of those can be a factor of 27. So we can eliminate those from our brains for a second. So now we just need to check 3 numbers. We need to check the number 3. We need to check 5. We need to check 7. Again, when I say check, what I mean is do 27 divided by 3. Okay? And you'll be able to use your calculator, and you're going to get 9. That tells you that 27 also has factors of 3 and 9. So therefore, 27 is composite. Okay? It has a factors of 1. 27 has factors of 1 times 27. It also has, don't mind those announcements, 3 times 9. So it has 4 factors. That's why it's composite. Here, I see this is even. Right away, I'm putting composite. Because it's even, I know it has a factor of 2. Also, I know that it has a factor of 10 because it ends in 0. I also know it has a factor of 5 because it ends in 0. Okay, so that's composite. Here, first thing I see, yes, it's odd, but then I look and say, oh, it ends in a 5. So it has to have a factor of 5. 5 times 9 is 45. That's composite. 49 is odd. So I eliminate all my even factors. So now I got to check 3, I got to check 5, and I got to check 7. I'll get my calculator out for this one so you guys can see it. Hopefully you can see it. This calculator is not the biggest thing in the world. Okay, we got 49 divided by 3. Whoops, that didn't work very well. 49 divided by 3. We got this big long decimal. Therefore, we've learned that 3 is not a factor. Okay? Now we bring it up again. We do 49 divided by 5. Now, you technically don't need to check this one because you should know that it doesn't end in 5 or 0. So you know that 5 is not a factor, but regardless, we get a decimal, so that eliminates 5. Okay? Now we got to check 7. Okay? So we're going to do 49, and we're going to divide by 7. And we're going to get 7. That tells me right there that this also has a factor of 7, so therefore it is a composite number. Okay? Okay, I can find common factors of 28 and 42. Let's find the common factors here. What you have to do is you've got to identify all the factors of these numbers. So 28, let's think about all the ways that we can multiply to get to 28. Okay, I know that I can do 1 times 28. Okay, I know that I can do 2 times 14. And if you're not sure, you know that it has a factor of 2 because it's even. Just do 28 divided by 2 to get the other factor. Then I can check 3. Okay, if you need to. Some of you probably are saying, no, I know 3 is not a factor. Well, let's just check it. Okay, so I'm going to do 28 divided by 3, and that gives me a big long decimal, so I know 3 is not a factor. Okay, so now we got to check 4. 28 divided by 4 gives me 7. So I know that 4 times 7 is also factors. Now you could go through and check 5, check 6, check 7, check 8, check 9. You could check all those, and that would be my advice to you, but you don't need to. These are all the factors of 28. Now let's do 42. I know that the obvious one is 1 times 42. I know that it's even, and that's 2 times 21 is 42. Let's check 3. Let's see if 3 is a factor. Okay? Let's do 42 divided by 3. I get 14. Therefore, I know that 3 times 14 is a factor. Now let's check 4. Okay? Let's do 42 divided by 4. Oh, we get a decimal. We got a decimal, so therefore, no, 4 is not a factor. We don't really need to check 5 because, again, that doesn't end in 0 or 5. But if you need to, 42 divided by 5. Nope, doesn't work. Okay? Let's check 6. 42 divided by 6. Oh, I got 7. So I learned that 6 times 7 is also factors. Okay? So I think I've done all my factors. Now you could keep going here and check 7. You're going to get 6, obviously, because 7 and 6. But now, let's look at our 2 now. So I have these factors for both of them. Now it says it wants to identify what these what factors do they have in common. Okay, and I'm going to do those in my red highlighter here. Actually, I'll use yellow. Okay, and I look here and I say, well, that one's easy. You can't see that. I use black. Oop, that ain't gonna work. Okay, I'll just circle them. How about that? Just to make it easier. Okay, so I see a 1 there. I can see a 1 there. So I know that my first common factor here is 1. Let's keep checking. Do they have a 28 in common? Do you see a 28 over here? No, let's get rid of it. Let's forget about it. What about 2? I see a 2 there. I see a 2 there. Yes, they share that common factor. All right, I see a 4 there. Do I see a 4 over here? No, I do not. It's gone. Let's check 7. I see a 7 there. I see a 7 there. So therefore, they also have a common factor of 7. I see 14 is my last one that I could even have in common, and I see a 14 there. I see 1 there. There are my common factors. Now, I don't have any left over here. I'm all done, right? So I don't even need to check these other ones because I know it's not over there because there was none left. There's your common factors, okay? Hopefully that made pretty good sense, okay? All right, I can find the greatest common factor. When you're doing this, the first step you got to do is you have to do the prime factorization on these, okay? Whether you're doing GCF or LCM, you always start with the prime factorization. Okay, now I'm going to take these. I'm doing greatest common factor, remember, and I'm going to stack them up. 2 times 2 times 5, 2 times 2 times 11. Now, since we're doing common factor, notice I'm looking for just that, guys. Just that, those 2 words. You look for common factors. I see that we have 2's in common. I see that we have another 2's in common. Okay, so that means we have 1 2 in common. We have another 2 in common. My GCF here is 4. Okay, let's do this last one now. Okay, of GCF, I'm going to do the prime factorization. 5 and 9, 3 and 3. Okay, 60 is going to be 6 and 10, 2 and 3, 2 and 5. And I'm going fast on this because I think you guys get that step. That's not the problem. Okay, so now we got to stack them. So 45 is 3 times 3 times 5. 60 is 2 times 2 times, let me see, 2 times 2 times 3 times 5. Okay, and then 75 is just going to be 3 times 5 times 5. Now this is where people get confused. They start doing all kinds of crazy stuff. Follow my rule. You only look for common factors. That's it. That's all you look for. Now, in order for it to be common, it has to be a number that appears in all 3 rows. And the first number I check here is I check 3. And I say, okay, 3's there. Is 3 in the middle row somewhere? Oh, there it is. Okay. Is 3 in the other row somewhere? There you go. My first common factor is 3. Okay, so that means my first common factor they have is 3. Now let's check for another common factor. I see another 3 here. Now is there another 3 in this row right here? No, neither row. So that one's kind of gone. Let's just forget about it for a minute because it can't be a common factor. So now let's check these 5's. I see 5, 5, 5. Oh, there's another common. They got that in common. Okay, so now I bring that down. Do 3 times 5. None of this other stuff matters. You don't look for doubles. You don't look for singles. None of that stuff. Okay, that's what gets people confused. You only look for common factors. If you have 3 rows of numbers, it's a factor that appears in all 3. If you have 2 rows of numbers, it's a factor that just appears in the 2. The greatest common factor of these 3 numbers is 15. Okay, let's go to the next page. Okay, here we go. I'll zoom out just a bit. It says I can find the least common multiple of 2 whole numbers less than or equal to 12. Don't worry about this. This will confuse you. This is just finding LCM of 2 or more numbers. Okay? So we bring this in. Again, first step, always do the prime factorization. Okay? Prime factorization's got to be the first step to all these. Okay, so I do 2 times 2 times 2 and 2 times 2 times 5. Okay, I look, oops, sorry, I'm skipping steps here, sorry. Now remember, when you're doing LCM, this is different. You look for triples, doubles, singles. Triples, doubles, and singles. Now, the first thing you should identify, there are only two numbers to start with. Okay? So we cannot have triples. We go straight to doubles. I see double twos. I see double twos. Okay? Now remember, I'm going to take one of those twos, and I'm going to cross one off, and I'm going to circle one. I'm going to cross one off, I'm going to circle one. I'm done with my doubles. Now I just need to circle my singles. And then everything that I have circled here, 2 times 2 times 2 times 5. I'm going to multiply that out, and I'm going to get 40. My least common multiple is 40. Now ask yourself, is 40 a multiple of 8? Yes, it is. You can do 8 times 5 to get to 40. Is 40 a multiple of 20? Yeah, 20, 40, 60. Yeah, it's a multiple. That's just a little check. I feel like I got that one right. Okay? Okay, let's do the next one. This is of 3 numbers now. So now I got to do the prime factorization to start. 2 and 2. Okay? 4 and 4, which becomes 2 and 2 and 2 and 2. 24 is 3 and 8. That's 3 times 8 is 24. Okay? Now I take those prime factorizations and I stack them. 2 times 2. 2 times 2 times 2 times 2. This is 4. This is 16. Now this is going to be 24. 2 times 2 times 2 times 3. Okay? Now again, since we're doing LCM, what are we looking for? Triples, doubles, singles. Okay? I see triples there. I see triples there. Okay? And I don't see any other triples, but what I'm going to do now is I'm going to cross off 2 of those from each. And I'm going to circle 1. Circle 1. Okay? Now I'm going to look for, I'm done with triples, I'm going to look for doubles. I see double 2s right there. So I'm going to take it, I'm going to cross one of those out, and I'm going to circle 1. Okay? We're done with doubles. Now the last step, I have to do singles, remember. Single, single. I'm going to do 2 times 2 times 2 times 2 times 3. It's going to give me 48. Okay? Let's go on to the real world questions now. Okay, if you can't read this, I apologize, because I really can't. I guess I can kind of zoom in and just kind of scroll along with it. Okay, Mandy is making emergency I don't even know how to say that word. It's like bouquet all over again. Forget that word. They're making emergency kits, first aid kits, to share with friends. She has 12 bottles of water. She has 16 cans of food, which she would like to distribute equally among the kids, with nothing left over. What is the greatest, there's your word, number of kits she can buy? That is the key word right there, guys. What is the greatest? When you see that word, you know this is a GCF question. So we know we're doing the GCF of 12 and 16. Okay, we got to start by doing the same thing we did up here, or that we did in learning target number 7, finding the GCF. That's all this is now. After you determine that, let's do it. So that's 3 and 4, 2 and 2. This is 4 and 4. It's 2 and 2. Okay, we got 2 times 2 times 3. 2 times 2 times 2 times 2. Okay, we stack them. Now remember, we're looking for, what CF stand for? Common factors. Look for common factors. I see common 2s. I see common 2s. Okay, and that's all I see. That's all they have in common. So I got 1, 2. I have 1 in common. I have another one in common. Therefore, we have a GCF of 4. She can make 4 kits, is what it's saying. 4 kits. Okay? So if she's making 4 kits, 16 cans of food, she's going to have 4 cans in each kit. She's going to have 3 water bottles because 12 divided by 4 is 3. Okay? But that's your answer. Okay? Let's go on to the next one. Love this question right here. Train A leaves the station every 14 minutes. I like to underline good information as I go. Train B leaves the station every 8 minutes. Okay? If it is 12 o'clock, I assume that's going to be important. I don't know yet. Right now, it's 12 o'clock, and both trains are at the station. What time, I'm going to underline that, will both trains be at the station at the same time? Now, right now, a lot of you are like, oh my gosh, I don't see the word least, I don't see the word greatest, I don't see most, max, smallest. I don't see that word. I don't see again. I don't see any of those things. There really isn't a word here you can key on. But what I'm trying to get you guys to see is when you want to know, are 2 or 3 things going to happen again? When are they going to happen at the same time in the future? We're talking about LCM. We want to know, when will these trains when will they both be at the station? Because if one comes every 8 minutes and one leaves every 14 minutes, they're going to always, a lot of times they're going to miss each other. Okay? Because 8 minutes are going to go, then that one's going to be there, then he's going to leave, and then the other one's going to come in. Okay, the other train. So whenever you want to know, when are 2 or 3 things going to happen again in the future, we're talking about LCM. So let's do that. So I take 14, I got to do the prime factorization. It's easy, 2 and 7. Okay? I have 8, that's going to be 2 and 4, 2 and 2. Okay? I stack these, 2 times 2 times 2, and 2 times 7. Okay? Scroll down here. Okay, sorry about that, I got kind of sloppy. And then 2 times 7. Now I'm doing LCM, remember, triples, doubles, singles. Now you should know there are no triples because did we have a train C? No, we didn't. You would have to have another train if you wanted to have triples. So we go straight to doubles. I see doubles right there. I cross off 1, I'm going to circle 1. Okay, I'm done with doubles, that's all there are. Now I'm just going to circle singles, 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 singles. So then I'm going to multiply everything there that's left. What I'm going to get is 56. Now, let's explain what that 56 actually means here, because a lot of you were confused on this on the test. This question is the same question, if you all remember, as the one that was like talking about one of them read a chapter every 27 minutes, the other one read every 45 minutes. And then it said, what time will they both finish a chapter? And a lot of you got kind of sucked into the mistake, and you put D. Maybe you remember that question. It was number 8 on your, I think it was number 8, if I remember right, on your formative. But this is the same type of question. The LCM here is 56. It's absolutely 56 minutes. Okay? That means that every 56 minutes, both trains are going to be at the station together. They're both going to be there. Okay? But again, every test is a reading test. Okay? Let's go back and see what the question is asking. It didn't say how many minutes will it be. It doesn't say any of that. It says what time. What time will both trains be there at the same time? What time is it? Well, they're both there, and it's 12 o'clock right now. It's 12 o'clock, and they're both there. We know that every 56 minutes, they're there together. So what we got to do is we got to figure out what time that'd be, 56 minutes from 12. And it is 12:56 p.m. Okay, and we could keep going on this. This is the answer, by the way. But if you want to think about it, go, okay, well, what would be the next time they'd be there? Well, that'd be 1:02. Some of you might say, well, Mr. Gears, I'm sorry, not 1:02, 1:52. Where did you get that answer? Well, I just added 56 minutes from the here. Because if it's 12:56, it's 4 minutes until 1. So that would leave us with just 52 minutes left. 1:52, that'll be the next time they'll both be there. Okay, then I could add 56 again and figure out what time it'd be. Because every 56 minutes, they are going to be at the station together. But that's the answer to the question, 12:56. Okay? Don't do this, because that's how you do the answer. But the answer is asking for what time. Let's go to the next page. Okay, last few here. Okay, then we'll be done. Lavinia has 9 glasses and 6 mugs. She would like to set them out in identical groups. Right there is always a kind of a nice little buzzword for you, with none left over in preparation for the dinner party. What is there's your key word, maximum number of groups? So when you see maximum, that's the same thing as greatest common factor. Max is the same as greatest. So we got to do the prime factorization for 9. Okay, 2 times 3 and 3 times 3. Remember, we're doing GCF, so we only look for CFs, common factors. So I see a common 3. That's all they have in common, so that is the greatest common factor. Okay? All right, Mr. Edwards cleans his bedroom every 10 days. Okay? He cleans his car every 15 days, and he takes a shower every 20 days. If he did all 3 of these today, in how many days will he do the same? Will he do all three on the same day again? Is basically what it's asking. And there's your buzzword. But again, think about it. Are we trying to figure out when something is going to happen in the future? Yes, we are. So this would be an LCM question. So let's do the prime factorization for 10. Will be 2 and 5. Okay. 15 would be 3 and 5. Sorry, my handwriting's starting to get a little sloppy. I apologize. 20 would be 4 and 5, and then 2 and 2. Okay. I think you guys are good with that, so I'm not going to harp on it too much. Okay. Now I'm going to take my prime factorizations. 2 times 5, that's for 10. 3 times 5 is for 15. And then 2 times 2 times 5. Okay. Now I'm doing LCM, remember, so I look for triples, I look for doubles, I look for singles. Okay. So the first thing I see right away is I go, okay, I see a triple 5 right there. Okay. I'm going to take 2 of those and cross them off. I'm going to circle 1. Okay. Now, there are no more triples because I got a 2 left up here, and I don't see a 2 in this row left. So I know there are no triples, so I'm done with triples. So now I got to say doubles. Is there a number that appears in 2 of the rows? Yeah. Even though they're not right above each other, they still appear, the factor appears in 2 of the rows. We cross off one of those and we circle 1. Okay. Now we have to do singles, and that's all we have left are singles. We multiply everything circled. 2 times 2 times 3 times 5 gives us 60. So that means every 60 days, Mr. Edwards is going to do all 3 of those things in the same day. So that means on the 60th day, from 60 days from today, he's going to clean his room, he's going to clean his car, and he's going to take a shower. That also means that on the 120th day, he's going to do these 3 things. Again, on the 180th day, he's going to do these 3 things. I'm listing the first 3 common multiples of 10, 15, and 20. So the answer was 60. That's all I was looking for, but I want you to see that you can also list the next several too. All right, last learning target. Okay, this is the one where you got to use the distributive property to help you on this. Okay, the first step when you're doing this, just a quick recap of what the distributive property is. If I had this, forget this isn't what you're supposed to do. I just want you guys to see it. What the distributive property says, it says if you multiply through, okay, in other words, when you distribute it, when you multiply the number on the outside of the parentheses by each number on the inside, you can do that. And when we do that, 2 times 3 is 6. Bring down my plus sign. 2 times 5 is 10. That is the same. These are equal to each other. They are the same thing. The only thing here is, this is what, you're not going from this and making this. You're doing the opposite. You're taking this, starting with this, and you're making it into that. Okay? Okay? So let's do it. The first step here, because it says you must use the GCF, you have to find the GCF of these 2 numbers. So that's where we got to start. So 24 is 3 and 8, and then 2 and 4, 2 and 2, right? Okay. 32 is 4 and 8, or you could use 2 and 16, doesn't matter. 2 and 2, that's supposed to be an 8, sorry, it's kind of sloppy. 2 and 4, 2 and 2. Okay, so now I'll do this down here, just kind of down here. This is 2 times 2 times 2 times 3. That's 24's prime factorization. Now 32's is 2 times 2 times 2 times 2 times 2. Okay, now we're doing GCF, so we only look for common factors. I see common 2's. I see common 2's. I see common 2's. Okay, so I'm going to use one of each of those. 2 times 2 times 2. Guys, this is not 6. A lot of you make this mistake. You have 6 here. 2 times 2 is 4. That's 4. 4 times 2 equals 8. So my GCF here equals 8. Okay? So now, I'm going to take that GCF and I'm going to put it outside of parentheses. Okay? Now I'm going to ask myself, what would I distribute, what would I multiply by to get me back to what I started with? Okay? In other words, I want this to become that. So what would I multiply 8 times to get to 24? Now if you struggle with your math facts, remember, you can just take this number, 24, and divide it by 8. That'll give you that other factor. okay? So that's going to be 3. And same thing here, what times 8 would give me 32 now? Well, if you need to, do 32 and divide it by 8. Get 4. That is your answer. Okay, that's the answer, but I don't want you to stop there. Always check it now. What's 8 times 3? 24. What's 8 times 4? 32. Isn't that what we started with? Okay. All right, now this one here, I'm going to skip the whole GCF step. You got to find the GCF. I'm just going to tell you right now, the GCF is 8. Okay, I think we can do this. I think you guys are good at that now. You're going to be fine. So we have to put the GCF outside of parentheses. Okay. 8 times what is 56? Again, if you're not sure, do 56 divided by 8. It'll give you 7. Okay. 8 times what would give you 48? 6. Now that's your answer, but let's check. Let's just make sure real quick. Okay. Let's do 8 times 6, 56. 8 times 7 is 56. 8 times 6 is 48. Is that what we started with? That's right. That's all you do. Last one here, the GCF. Okay, when you do 16, the prime factorization is 2 times 2 times 2 times 2. That's 16. And the prime factorization for 32 is 5 2's. Okay, so let's identify what they have in common. They have 2's 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 in common. Okay, so that means their GCF is 2 times 2 times 2 times 2. That is 16. So now let's put 16 outside of our parentheses. 16 times what is, get us back to 16? 1, right? 16 times what would get us me back to 32? 2. Your answer is 16 parenthesis 1 times 2. Now let's check just to make sure. 16 times 1 is 16. 16 times 2 is 32. So that clears it up. Okay. This should have been a good review. Go back and watch other videos. These questions, guys, these questions are just from the test. Go back and do other problems from the worksheets, the notes. Do whatever you got to do. Message me on Schoology if you need to. I'll be around my phone all night, okay? So please, please, please study, study, study. See you guys.